Hello, everybody.
Hello.
Welcome to another week of coding. So,
Yeah.
how is everybody?
Yeah, good.
Good.
Yeah, not too
Good,
bad.
ready to go.
Good.
Right, Horlixs, do you want to do the chat?
Yeah, I can do.
Yeah.
You've the coffee machine started up. Yeah, we've got D Harrison. Very good evening, Alex, Mark, Jack. Hope you're all well. Thank you very much, D.
Hi, D.
Hello, D.
Sorry about the racket. There we go. Yeah. Then we've got Yorkshire Crafter. Hi, everyone. So, hi, Julie.
Hi, love.
We've got Dave Matt Builds. Good evening, everyone. And to Horlicks, Mark, and Jack, have a great show tonight. Thank you very much.
Evening, Dave, Matt.
DS Models and Vintage. Hello, everyone. Good luck with coding. And then we've got
Hey,
some
Dave.
traffic lights and some things and a 4-leaf clover. So,
Hi, Dave.
Yeah, I'm going to need it, I think. D Harris, good evening at Dave Mack. And then D Harris again. Good evening at DS Models and Vintage. So, yeah, lovely. Dave Matt Builds. Good evening, D at DS Models and Vintage. Dano's Universe. Hello, everyone.
Hi, Dana.
Hi, Dano. Dave Matt Builds. Hi, Dano. We've got D Harris. Good evening at Dano's Universe. We've got Ian. Hello. Hi, Ian.
Hi, Ian.
Hello.
Hope you're well. I've got Johnny Dave. Hi, all.
Hi, George, Dave.
Hi, yeah. And then, yeah, we've got Alan Key. Hi, all. Hi, Alan.
Hi, Alan.
Hi.
So, yeah,
Okay. Right, so it's over to me. So I better share screen. You know when you just really just don't feel mentally prepared for something?
Yeah, I feel
Reading
like that
tonight.
right now. Yeah. So,
I'm all set up, and before the show, I was getting myself ready, and I knew what I was doing. And as soon as you hit that go live button, my mind's just gone blank.
Precisely. I'm also just going to change my camera to that one.
I will warn people. This is like a headphone warning. That
Yeah.
it's a noise stream. That
So-
it's really bad.
Tonight's lesson 6, active buzzer. So in this lesson, you will learn how to generate a sound with an active buzzer. So we need an Arduino unit, we need an active buzzer, and we need FM wires. So that's female to male. If I just go full screen a second, the way you find that out is that's basically a male side, that's basically a female side, and basically as life is, things like that happen. So I can't put it any other way. So right, back to the thing. So component introduction. So buzzer. Electronic buzzers are DC powered and equipped with an integrated circuit. They are widely used in computers, printers, photocopiers, alarms, electronic toys, automotive electronic devices, telephones, timers, and passive and other electronic products for the voice devices. Buzzers can be categorized as active and passive ones. Turn the pins of the two buzzers face up. The one with the green circuit board is a passive buzzer, while the other enclosed with black tape is an active one. So if I go back to my camera, I've got both these out. So that one there is an active buzzer. Passive buzzer, sorry, yeah, because that's got the green circuit board.
Mm-hmm.
And then got the enclosed one there, that's the active buzzer. Right, Mark. It says the difference between the two is that the active buzzer has a built-in isolating source, so it will generate a sound when electrified. A passive buzzer does not have such a source, so it will not tweet if a DC signals are used. Instead, you need to use square waves, whose frequency is between 2K and 5K to drive it. The active buzzer is often more expensive than the passive one because of the multiple built-in isolating circuits. Excuse me. Now, we were having a bit of a laugh at this before the stream, wasn't it? Apparently, you have to wash these. But
Yeah.
Yeah, I don't get that. It says on the front, please, remove after washing. I just don't get it.
no, neither do I.
Unless it's like I don't know, unless it's a sticker for something else. It's just being used for this. I don't know.
Yeah.
Oh.
Okay, so we're just going to make up a very basic circuit here. And then basically, that's the circuit we're going to make. So we've got one going into pin 12, and then we've got obviously one going into the ground.
You're not showing this one.
Yeah, there is a male and female on this. Sorry, positive and negative. The positive is the longest pin. So,
Also has a plus above it.
Yeah.
On the other side of the buzzer.
I always use red and black wires for power. I don't know why.
That's good. At least you know.
It's a good habit.
Good troubleshooting, if you have problems.
Yeah. Right, so going to ground. No breadboard tonight.
No.
Just going to pin 12. There we go. Right, so that's now wired up, but we now need to go and look at the code. So,
You know that thing you sent me?
yeah.
It's for next week. It's for the passive buzzer. Yeah, you found it in lesson 7. I think you might actually have the wrong code. You might want to check that you have lesson 6 code, not lesson 7 code, because you said that's where you found it then.
Right, where's my thing on? I did have it. Right. I had it on here.
Code or the thing?
The code.
Just open it from the folder.
No, I don't want it in Espanol.
Just open it from the folder.
So
Spanish
funny.
lesson.
Yeah. Right, it's like lesson 6, making sounds. Active. Right, I'm opening it up now, and then we'll go over to it.
Yeah.
Does take a while to load up, though, doesn't it?
What, load to the Arduino or load the program
code.
itself?
Right, Alex, you're going to have to talk me through this. Right, here we go. So we've got INT buzzer, 12. So it's coming out of pin 12, I get that. The pin of the active buzzer, void setup. Pin mode, buzzer, output, because the buzzer is the output.
Yeah.
Then we're going to loop it. Output and frequency for, I think that's a frequency.
Yeah, I think so. That's a bit. I was looking at similar code actually this evening for LED controls, and I need to do a bit more research on that.
Right, okay.
I'm not sure whether Jack might know any of that.
Some of it.
So it says here, digital write, we're putting the buzzer on high, and then wait for 1 millisecond, and then it's going to low, so that's what's going to cause the high-pitched noise. And then delay, again, wait 1 millisecond, output another frequency. So, it's different frequencies, I believe.
Yeah.
So, yeah, because if you look, that's 100 and above is 80. So 100 is a higher frequency than the other one. Yeah. Digital write buzzer high. Wait for 2 milliseconds. Right, okay, yeah. So I think I've understood that for the first time in weeks. Okay. Right, so I'm going to plug in and upload the code. Like I said, this could sound quite bad. So, but I can just pull a wire out, can't I? Okay, let's go. Compiling sketch, uploading.
Yeah, I can hear it.
You can hear it?
No.
You can't hear it?
No.
Bring it closer to the thing.
Okay, let's make this louder then.
God, that's really quiet. I suppose
Yeah.
it's
His microphone is the frequency of his microphone. It's not letting him. That's why.
Okay, well, let's mess around with this. I mean, you can't exactly blow it up, can you?
No,
I suppose.
it's not.
Okay, let's try 150. So from 80 to 150. Plug it back in. And let's upload it. Still quite low in volume.
Okay. Yeah, because it's always going to set the volume. You want to change the volume of a buzzer.
All right, that one is loud.
That's mine.
Right. Okay. I'm going to have a mess around now. Because I just can.
Yeah. When I say it, and that's, you know, so you learn.
Yeah, I'm slowing the between the two frequencies, I'm slowing it down. Let's do that. Just because I want to. Can sort of hear it.
Yeah, see, I can't hear yours, Mark, at all. I think it's because of the frequency of the mic and stuff.
Yeah. Can you hear it
I can
now?
hear that one. Yeah.
All right. Sorry, people. So yeah, I've basically messed around with the code. Let's set that at 1,000.
That's
Right.
fine.
So yeah, if you want 1,000, you need to. You're editing, Mark, at the moment. The comment.
Yeah. So you have
Because
to just
the / so you need to do where it says delay the number in the brackets. So you want 10 for 1,000.
Right.
Alarm anyone?
And I take it I need 20 for 2,000.
Yeah.
Right. You don't need when you're changing one. Right. So let's make this a little bit simpler because obviously, so from you see where it says for the first for loop where it says for I whatever, the first one.
Yeah.
Underneath it says output a frequency. So before that for, put 2 forward slashes.
Before it.
Yeah, put 2 forward slashes.
Yeah.
Right, and then put 2 forward slashes on every single line up until the next for, before everything.
Before. Right. So there's only one, isn't there, down there?
No.
What?
You see, the line underneath has a bracket.
Where?
The line underneath the for,
Yeah,
there.
Open
Put 2 forward slashes in front of that. In front.
In front. Yeah.
No.
And then another one down here.
No. In front. That's after.
Yeah.
Right, and then go to the next line.
Here.
Yeah, and then put 2 forward slashes again.
Yeah.
And then go to the next line and do it again. All the way down until the for loop, the next time it says for.
Right.
And then on the bracket at the bottom as well.
On this.
Yeah, before that.
What's this doing?
That's commented it out. So that this now thinks that this code is invalid. It's a comment. You know where it says output another frequency? That's what a comment is.
Right.
So basically, you don't need this. I don't know why it's given us 2 for loops for the frequency for the first lesson on this, but it's really overcomplicated because you only need the second one.
Okay.
You only have to change one. So now it'll give you a consistent turn, or it should.
Right, plug it into pin 12.
That's because you got a delay. You've got a delay. If you put the delay back to 2, it should give you a consistent turn. On the one underneath.
Yeah.
Don't worry about that code now because you commented it out. I mean, we could have just deleted it, but I just wanted to teach you about comments and stuff out.
I can get rid of that.
No. Well, you know the code that all the lines of code we put the 2 forward slashes.
Mm-hmm.
If we got rid of that, it wouldn't make a difference.
All this. Right, so change your 2 to 1.
You can do, but I'd leave it at 2 for now, and then change the 20 back to 2.
Right.
Yeah, and then upload it.
Right. This is the last messing around I'm doing.
So you see,
Right.
it's one turn.
Right. Okay. Yeah, I get you. Okay, so that's at least I dared to play around with the code. So there we go. So if I stop sharing, I'll catch up on comments and over to Horlixs for his more advanced.
Well, if it works, it should do. So we've got DS Models and Vintage saying hi to Ian, Dave, Mac. Jolly Dave says hi, Ian. D Harris says evening, Mr. Campbell, and all on the other side. Ian says hey, Dave. Jolly Dave says hi, D Harris and Dave, Mac. Jolly Dave says hi, Dave, say. D Harris, after tonight's lesson, Alex, what was the fix for last week's button issue? Yeah, I'll come on to that in a minute before I do tonight's code. Because I'm going to write some new code from scratch again tonight. And so I've still got it set up from last week. So before I can disrupt this, I'll show you what it was. And I still can't get my head round, but I'll explain in a moment. Jay's channel says, hi, I hope everyone is okay and well. Thank you, Jay.
Thank you.
Yes, sir.
David Bassett, good evening to you all. Horlixs, Mark's Modz, D Harris, DS Models and Vintage, Dave McBill, and Jacklttv.
Hi, David.
Yeah.
We've got David Bassett again. Good evening at Danny's Universe. Dave McBills, good evening at David Bassett. Yorkshire Crafter, hi again at Jay's channel. DS Models and Vintage, hi David Bassett. Jay says, at Yorkshire Crafter, hi, I was talking to a twin on another stream, laugh out loud. David Bassett says, having missed the start, this all sounds like nuclear physics to me. Lost me.
It's quite simple. Just I was teaching about comments and how it doesn't actually affect the code and whatever. I can go into an entire thing about it. I can do an entire coding basics if you really wanted me to.
On my code that I'm going to fix this LED button problem with, I've actually used comments, comment flashes, because I've written 2 lines of code and I've commented one out so that it invalidates that bit of code so that when I show you, it's going to be a bit easier and quicker.
Yeah.
George Craft says, my twin cheeky, laugh out loud at Jay's channel. Jay says, Yorkshire Crafter, no comment, laugh out loud. David Bassett, who set off the smoke alarm? Yeah. David Bassett again, good evening at Geordie Dave. Dave Mark Builds says, hi, Geordie Dave. And D Harris says, good evening at Geordie Dave and David Bassett. That is some of the chat up to date.
Fantastic. Right, over to you, Alex.
Right, okay, here we go. So first I'm going to say that I've had to change the software. Oh, sorry.
Well,
I've had to change the software because I had the updated version of Arduino and it was causing me some problems. So I've actually gone back to the older version of this. That's why it's white again this week. So I'm using the same as what Mark's using again. So the newer version, there's a few bugs with it. So
yeah.
I need to delete that because I was having a play earlier. So let me go to my desk view and let's have another look at what the problem was last week. So we left off with me being quite frustrated because this wouldn't work. So this is still the code that we had on from last week. And if you remember, I did like a emergency vehicle light flashing blue and red. The aim was to push the button and it would do something, and it's not. I've double checked, triple checked. The wiring is okay. Now there's two ways of wiring this. You can use what I've done in my code is here, this input pull up, and that uses the onboard resistor so you haven't got to wire in more resistors. So that bit is correct. Although, because I'm using the pin on the button, you've got one that goes to ground and one that goes up to the pin. In my case, it's going to pin 2. So there should be 5 volts at this pin 2. When you push this button and hold it down, that introduces the ground, and that should pull that line down to 0 volts because it will go through and down to earth. So on the code, if we go back to the code, I wrote this while statement. While the button red is low, so when the button is pressed, start the loop. So that statement is correct because when I bring that pin down low, if you follow me, that should start and the button should do something because we're pulling this pin low because it's connected to ground. And as you can see, nothing happens at all. So the fix for this is to change this low to high. And that's all it is. Now, I don't know why, because as I say, the pin is high already. So by making it high again, I just don't know. It's not right. It shouldn't be doing this, but it seems to work. So if I upload the code now, you'll see we've just got a solid red light. Now, the solid red light, if I go back to code, is because in the setup, we've told that LED to run high before anything happens. So if I now change that red LED to low and then re-upload, you'll see that we have no red light at all. But when we push the button now, it runs our code we had. So that's what I was, and then when we, and then that will just continuously run. So that's the next bit. Because I've put this bit of code in the setup, that's going to tell Arduino that once we've pushed this button, again, I really don't know why this is set as high, because this should be really low. Because when we pull that pin low, it should start this. But as I say, I can't work out why it's doing that. but high seems to work. If it's in, I don't want to baffle you too much, but if we have that bit of code in the setup, I'm going to reset the boards. We've got a little reset button up here. When we have this in the setup, the button press, when we push it, it will automatically start running our loop, our main loop function, which is the code we wrote. So now, if I comment out this, so as we were saying, if you see, you've got while and digital read, which is all orange, which means it's doing something. If we double, if we do that, it will grey the whole line out, so it will not take that line of code into consideration when we upload the code. So if we then re-upload this code, what should happen? Yeah, it just runs our code straight away. Again, button doesn't do anything because we've taken that comment out. That we've now marked that as a comment, which is basically hidden it from the code. So if we now down here in the loop, I've basically copied the same bit. If we undo that part now, and we're going to have to change this to high as well, because as I say, I don't know. That's all it was last week, just the low to high. And if I change that to high, so I've commented here, when the button is held, it will start the loop. So the difference is, if we upload this now, oh, we've got a problem. What's going on? Hang on. Hang on.
Let's scroll up to the top. Are you? No. No. Wait, click on the. You know where the error is at the bottom? Click on the bracket.
Yeah, I think I need to add another one of them.
Yeah.
I think.
Yeah. Avoid. Yeah.
Yeah, there you go. Mm-hmm. Well, actually, maybe this does need to go. Actually, hang on, that didn't work. Let me change that back to flow. See, this is what I don't get. We've got. See, this one seems to work while the button's low, and it's got the right.
D says line 17, 2 times /.
Yeah, I've done that. Yeah, I did that. It's the first thing I did. There you go. So that's taking that out. So what was I saying? Yeah. So in the voice setup, if you have that in the setup, when you push the button, it will run the loop. Okay, and then if we put it in the loop, it should just run. So here we go. I've uploaded the code. So now when we hold the button, it will run the loop. When we let go of the button, it stops the loop. Now you'll notice that we've got a red LED on after we did that. So if I reset the code, it's off, hold the button, runs the loop, let go, goes to a red light. So what we need to do to fix that is it's the last bit of the code here. I think. Hang on. Where are we? That's low, low, low. I think it's this here. We'll put that to 0. No, it's not that. Oh, that's strange. I'm not quite sure why that's doing that now. It'll be in the code somewhere, easily turned off. But the point I'm trying to make is, so now when you put it in the loop, it will only activate the code when you hold the button down. So there you go. That is that was the fix. So right. So let me just turn this off because we're going on a bit. Just before I carry on, I just need to show you this as well. This is that little gadget I was telling you about I had to test components, which has been great. It was only a couple of quid. I think it was eBay or Amazon or somewhere like that. You just connect a battery to it. And it's a component tester. So you've got little pads here for surface mount components, like little capacitors and things, or you've got like the this grid here. So what I can do is put a resistor in. It's just a lazy way of checking resistance and components without reading the lines. If I put that resistor in there, just as connecting to two plugs, it will test the component and it will tell you what it is. So this is a 220 ohm resistor, which is exactly what it is, because we've been using them for the LEDs. So if something's broken, it's a good way of testing things to see if components are damaged as well. So this is quite good to have while you're, especially if you've got a load of LED, components like me. I mean, I've got this little pot here, and it's got a load of loose resistors in there. So you can just pop them in and see what they are. You can also test LEDs with this. So if I put an LED in, doesn't matter which way, the polarity doesn't matter on the tester because it does it automatically. If I plug an LED in and test it, you'll see it should blink. And then it tells you it's a diode, and then it's working. So this is another good way to test LEDs in case you've burnt them out.
What does it do when you put an RGB bulb in there then?
Right, well, let's find out. I've lost it. So this will be more complex, actually, because you've only got 3 pins. Let's try first floor.
Oh.
It says 2 diodes.
Yeah, because one on the end is the red.
But we should have 3.
Yeah, well, I think flip it around.
The only reason it's doing that is I think because you've only got 3. So you've got you'll notice that they're labelled on there. You've got 1, 2, 3, 1, 1, 1, 1, and then you've got 2, 2, 2, 3, 3, 3. So I think if we had a 4th one on here, it would register. So yeah, it could be a bit more complex with these. So it's only reading 2, because there's only 3. Let me just swap this round. Come on. Is there any problem with this? Because there's like
so many, yeah.
Prongs. There we go. We test that one. Yeah, 2 diodes, but it flashed a couple of colours, red and green.
Yeah.
So it's not detecting the blue because there's not enough pins on here. I think you can get different kits that have more numbers on. This is just a basic one. It was about 3 or 4 quid.
Wow.
So yeah. Anyway, so that's that. I'm going to write some code, hopefully, cross fingers, if it works first time. So let me get all this out.
While you're doing that, I'll catch up with chat.
Okay.
D. Harris says, evening, Yorkshire Crafter. David Bassett says, good evening at Jacklttv Channel at Yorkshire Crafter. Pepsi sends her love and lots of licks. Jordy Dave says, evening at David Bassett. Not reading those other 2 out. I did read this one out, line 17, 2 4 slashes. And then we've got Dave McBill says, Horlicks, I still can't get 3 of the diodes to work on my Titanic model. I've put new resistors in and resoldered, made sure everything was correct. Do you have any advice?
Oh, God. Well, the only thing I can think of is that either there's no power getting to it somehow. So I'm guessing you've checked with the multimeter to see if there's voltage there. The second thing is just maybe double check that the polarity's right. Because obviously if you wire up a diode wrong way, it won't light up, as you're probably full aware. And the third thing is that the diode's blown somehow. I mean, if they're new diodes, there is every possibility that some are dead on arrival. Depending on where they've come from, you do get some. I think with this kit, there was a couple of LEDs that didn't work at all, and I had to bin them. That's all I can suggest, really. Apart from that, if all the others are working, that's the only three things it could be. So just check the voltage, check the polarity. If not, it could be the bulb, the diode's dead. I mean, the only other thing you can do is unsolder the wire into it and solder a temporary LED on, another one on, to see if that has a different result. So, yeah, that's all I can think of, really.
Okay. And then just three more. Yorkshire says, evening all on the other side. Jay's channel says, please give a big thumbs up for tonight. Thank you, Jay. Jay's channel says, and David Bassett, higher to you and Pepsi. And Dave McBill says, on the same strip, all the others are working except them.
Right. So perhaps, yeah, it's either going to be polarity wrong, but I very much doubt it because obviously you've done it and you know your stuff. So maybe they're just dead LEDs on there.
Maybe.
It's it's the only thing I can think of.
Right. That's chat caught up with.
Cool. So I'm just putting some. So what I'm going to do is try and I'm just going to do replicate the front of a vehicle, for example, because at the end of the day we're talking about basic mods to maybe do to your models or whatever. So I'm just going to mock up some headlights, for example, and that's what I'm doing now. So there's one of the headlights. These are white LEDs. And two LEDs. So they're the LEDs.
As we can tell, Horlicks likes his wiring all nice and neat.
Yeah. That one's a bit longer, but never mind. So we've got two LEDs. Let's get them in pin. So we want that needs to jump over to negative rail. That one needs to jump to negative rail. It's all good fun, isn't it?
Aye.
That we're going to have the white LED on pin 13. So I'm actually going to need to write this down so I know. White LED on pin 13 and pin 12. So I could use white wires, but I'm limited on wires at the minute. So 12 and 13, we've got white LEDs, so headlights on your model. We're then going to use 2 amber. So, where's my tweezers gone? There they are.
Wait, who's that on? Wait.
That's mine. Thank you, Jason.
Yeah, I was thinking that.
Thank you ever so much, Jason. That's lovely. So I'll put this up. Jason, you can be like, get yourself something for the Arduino. Loving the lessons. Wow. Thank you very much.
Yeah, it's kind of wanted to bring a little bit of attention to that.
I've never seen that come up on StreamYard.
Yeah, it does. It's different.
Yeah, I've never seen it come up on StreamYard before.
Wow.
Yeah. Just a little bit of chat. We've got D. Harris says, at Dave Mack, is it at the end of the strip? And then Dave Mack says, thanks, Horlicks. I'll give them one more once over.
I'm going as quick as I can because this is the bit we've still got to write the code, but it shouldn't take too long. So what I'm, as I said, what I'm trying to do is replicate the front of a car or the model. So what we've got, and I'm trying to, you know what I'm, as Mark said earlier, you know what I'm like with wires.
Yeah.
But also that it's easier to see what I'm doing, like how I'm wiring this. And, you know, if I start whacking wires in everywhere and it looks like spaghetti junction, you're not going to follow what's going on. That was too tight. Right, okay, so that goes in there. So we've got amber LEDs for indicators, headlights. We've got the resistors, they're 220, they should be. 1, 2, 3, 4 on each positive leg. You've got the negative on the other legs. So the positive of the white ones are in pins 13, 12 and 13. We want to have amber, which let's use orange. Oh no, we've already used orange. Right, let's use green, red. Let's use red for the indicators. No, we're going to use yellow. Sorry, because I need a longer one. So we're going to have amber in pin 2 and amber in pin 3. Cool. So we've got all of them wired up now, and we're going to add some buttons. So we're going to have button over here, and we're going to have another button on this side of the breadboard, and then we'll have them in green, I think. So we're going to earth the buttons. So we'll ground them. So let me change that. So much pressure, isn't there? Because I'm wiring all this up. I'm just praying it's going to work. So I've left grounded one side of that button, and then I'm going to get another one of these. I don't even know where I got these little pins from. I think I found them in a load of electrical junk that's almost thrown out. And I went, no. Oh, pushed the wrong button.
Whoops. Oh, I missed that.
That's all right. So I've grounded the buttons as well. So they're going to ground because they go down through there. And then let's do green for this button. And let's put that in pin 7. And green for this button, which will be pin 6.
Thank you, moderators, for sorting that out.
Right, it's as neat as I can get it. So that is all the connections made. So let's try and write code to work. So here we go. So we want to close that. No, I don't want to save that. And oh god, I thought it was going to just close the tab. Right, there we go. Yeah. Right, we've got brand new code. So move that for a moment. Move that. So first of all, we want to get that down a bit. We want to do our variables. So we want int. Right. Amber 1. Oh, what's going on with this computer? In Amber 1, and that's going to be equals to pin. Go off at Amber. Here we go. 3. I think. Let's have a look. Yeah, so pin 3, and then we want int Amber 2 equals to pin 2. That's them. We want int white 1, the headlights. We put them into pin 13. And then int white 2, which we put in pin 12. Oh, so we've got our LEDs in. So now we want to put switches in. And we want to call that button 1. And that is in, what did I put that in? 7. And then int button 2 is equal to pin 6, I believe I put that in. Did I put that in 6? Yeah. Okay, so that's the variables done. So we've got 2 ambers, 2 white LEDs, and there you go. Let's move this back up. Oh, Control Z. Too far. Redo. So in the setup, we are going to do. We need to define. We need to tell it what the pin modes are. So we're going to do pin mode. Then I will copy these in a minute. Save writing it all out. Pin mode amber 1. And that is going to be an output. So we want output. Close bracket. Okay. Amber. So pin mode amber 1. So pin 3 output. Let's copy that. You want 4 of them. Right, and then change that to 2 white and white 2. So they're all outputs because they're LEDs. Then we're going to want Control V. Let's do another couple of them. Pin mode, we want button 1 is input pull up. Let me just copy that line. Button 2, input pull up. There we go. So what I want to do, because I don't want a loop or anything on the white lights, because they're going to be headlights. So what I'm going to do here is do digital right, so that when the code starts, we're going to do white 1 high. I'm going to copy that again. So because this is in the setup, both of those white LEDs should be on all the time, no matter what we put in the loop function.
Yeah.
Okay, so then we're doing the loop now. So what I want to do is if statements. So if I do if, right, let me think. If, I'm just trying to run through it in my head. So if digital read button 1, so We said, hang on, button 1 is pin 6, isn't it? Oh no, 7. Yeah, 6. 6. Button 1 is 7. Yeah, that's fine. So if digital read button 1 equals low, close bracket, then we're going to do another bracket. Hang on, let me just separate that just so it's more easy to read. Tab. But yeah, if button 1 goes low, we're going to put our loop in here. This is what we want it to do when we've pushed button 1. So I'm going to do digital write oh, what was that?
One on my side.
I think it's because I'm holding the button down. Digital write amber 1. So this so amber 1 is going to be the LED more towards the button 1 switch, if that makes sense. But obviously you can name these whatever you want, because everything up here is what you want to call it. It's just so I know when I'm writing the code. So digital write amber 1, we want that. So when we push button 1, when button 1 goes low, we're going to flash. I want to flash the amber. So let's do high. High. Then I'm going to delay that by 2000. That's it. Digital delay that by 1000, and then digital write. Once I've done this, I can start copying and pasting. I need to get the main loop in first. Digital write amber 1. We want to make that low. So also, I forgot to mention, you don't have to use high and low. High is 1, low is 0. So you could type 1 in there. Well, some parts of the code, no, not in that part. Forget that. Some parts of the code you can type 1 or 0, but it's not working on that one. Then we're going to delay 5000. And then we've got the close bracket for that. So if button 1 goes low, it should flash that on and off and turn on. Basically, our headlights are going to come on, but then when we push the first button, those should flash. So let's upload that and see what happens to make sure I'm going down the right track here. So I'm going to upload. I'll bring you back to desk view. Oh no, hang on, what's going on?
I found the error.
Yeah. Oh, what's going on here? Oh, it needs me to save it first. Hang on.
I know where your error is.
Yeah. So do I. I've just seen it. There we go. Wrong
And
one.
there's another one.
Is there?
Digital read button 1 at the top low hasn't got one after the down there.
Yes, I don't think that one needs one because
Right.
we're doing the equals after that.
Right.
But it, we'll see. That should work. Yeah.
Yeah, it's working.
Right, hang on. What have I done here? 3. Hang on. So I've numbered the things wrong. 1. Let me swap these pins around. 2, 3. And I'm going to change these to 500. Oh, you're following this and you're not bored.
I am.
What, you're bored?
No, I'm following it.
Right, I've uploaded the code to the Arduino, so let's go. So what we should see is plug this in, headlights should light up. There we go. So that's our headlights on our model. Now when we push this button, it's going to blink this LED. There you go. So that's your indicator. So that's what I wanted it to do. So let's go a bit more. They're really bright. I really need like a better resistor in them. But yeah, you can see where I'm going with that. So yeah, we hold that button. We've got our blinking LED on that side. So it's going to plan. It's going to plan. So what we can do now is do here. So we've done that. So after that bracket, we're going to go else if I think that's what we need to do. Hang on. No, see, this is not quite right actually, because I've done this. Oh god, here we go. So this is where you lose it. It's all right, but then you lose your train of thought. Right, hang on. What do I want to do here? This needs to change to I need to change this to if digital read, right, so if button 1 is low, or can I do it a different way? Right, let me copy this. I might be able to do it a different way. So I'm going to copy that. Paste that down here. Do button 2. Amber 2. Amber 2. See what that does. Oh, no, hang on. We need to get rid of the else if. Yeah, that's right. So I've copied that. So if button 1 is pushed, it's going to flash amber 1, so one of the LEDs. And then if we push button 2, it should do the other side. So let's go back to view. So we've got our headlights on. Push this button, we should have this one flash. We push this one, we should have this one flash. So there's our indicators.
Awesome.
But we can go a bit further than that, I think. So if we go right here and go else, I think I can do an else after this because I've got 2 ifs. Yeah, I think that should be right. So if I do else digital button 1 is high, then we want to do and digital read. So we're telling it to read the switches, and that's what digital read is. Button 2. Yeah, hang on. Sorry, you can't even see what I'm doing. Just realised. So I've done here, after that, I've done an else. So else digital read button 1 is high, and digital read button 2 is hang on. Digital read button 2 close bracket equals high. If both of them are high, which means not pushed, we are then going to digital write amber 1 high, delay, and no, take the delay out of there. So I hope you see where I'm going with this. Amber 2 high. And then delay that by ½ second. Then we're going to do digital write. Let me just copy actually, save a bit of time. We're going to do them low. So what I'm hoping is if we push button 1, we get the left indicator. If we push button 2, we get the right indicator. Else, if both of the buttons are high, not pushed. Oh, yeah, if both of the buttons are high and not pushed, it should just run like a hazard light.
Okay.
So, hang on. Yeah, it should just run like a hazard light loop. Yeah, let's see if that works. Exit status. Oh, right, okay. What I've done wrong here. I forgot to put the bracket. Oh. Do I need to put one of them in there? No, that's not working. So then we want to. Of course, we need to add another delay. We're going to delay that by 500. Close bracket. Right. Right, so did you follow that, everyone? So let me just go through this one more time. So we've told the code to read button 1, left-hand button. If that's pushed, we're going to flash the left indicator. If button 2 is pushed, we're going to flash the right indicator. If nothing is pushed by else, digital read button 1, if that's high and button 2 is high, so both of them not pushed, we should flash both of the LEDs to be as hazard lights, for example. So the aim of this is if you've got like a modeling and display cabinet and you want it to be sort of, interactive, you could, have 2 buttons on it and let people have a play. So let's upload that.
I can feel a mod coming on here.
Right. So with that, we're going to plug in. Code's written. There we go. Look, we've got flashing indicators, hazard lights even. So remember, these are representing your headlights because you want them on all the time, really. And we've got flashing indicators. But when we push button 1, it's going to override that code and just flash the left indicator. Oh, I'm not quite sure why it's doing that. Why is it doing that? Right, okay, we need to amend this. We need to amend, you know what it's like, so well, I'm going to copy this. I think we need to add this in here. Upload that. Will that work? If digital read button is high, we want to do that. Oh God, this is getting a bit complicated now. Hang on. I'm just playing at the minute. Once I get it working, I will. Will that work? Else without a previous if, but I've got an if here.
Is that a previous if? If this.
So
take out the else from in front of the if and just see if that changes anything. If not, I have another solution.
well, we've got some weird results going on with that bit of code. We have indicate left, right, and then hazard.
Okay.
That isn't quite what I was trying to tell it to do.
Right. Okay. Now try. Right. If this is this. Right. So maybe it needs to, because you've closed the brackets. So you see where obviously. Yeah. So where it says it, you know, the second if.
Yeah.
If you change that to, I don't know whether it would be elif or else. It's probably else if. But if you get rid of the bracket before and after it, on the lines above and below. Yeah, that one, and then the one, and then the one above it.
This one.
Yeah. So now that bracket, and then change the if to else if.
What, here?
Yeah. And I'll try and run it. Right, try write L if. Yeah, like that. No, all one word. Yeah, like that.
Not declared.
Not declared in the scope.
Yeah, because when I do that, it does go green, but it's. Oh, okay. So let's do else. Oh, hang on. Else digital read button 2, low, high. Right, let's see if that.
Else that previous if, but it is a previous if.
Oh, so maybe does it need the bracket back?
Maybe try that. And then
We put them back for a minute.
Maybe.
Oh, here we go. It's because of that. So, oh, right, okay. So if digital read, right, so if button 1 is low and the button 2 is high, we're going to do that. Else, we're going to digital read button 2. If that's low, then if I copy this line here, actually cut, put that in there. Else if. Right, let's see if I've broken this. Oh, right, yeah, it's done this. Need a previous if. So, right, okay, edit, undo. Edit, undo. That's that. Right, so if, else, think it might be that. Killing that, actually. Try else if there. Because I'm not sure where the else if needs to go. Whether it's in the middle or the end. Does that work? No. Expected that before token. Okay. Else without if.
Is it because just above else digital read button 2 low, there's no the things the thing underneath, shouldn't that be above it? On line 34.
Anything else? Just a
Yeah, I mean,
Open it. You need an open bracket on.
yeah, that's there.
Right.
Yeah, that's fine. That's fine. The problem. Hang on, expected.
Then else if another condition, do that. Try changing both to else if.
Let me just put this back because it's not happy with that. I'll fix that one. Let's try that. Hang on, let me just try and fix the code. Right, so he's banging on about previous if.
If this, do this, if that, else if, read, that. Because what I'm looking on the Elegoo Arduino code thing, and it's saying exactly what you've done. So I have no idea.
Well, let me delete this bit of code for a moment. That should upload, shouldn't it? So hang on. If button 1 is low and digital read, but if button 2 is high,
Did it work with them all being just if? Or did that not work?
I think I tried that and then it did some funny results. Right, let me. Right, if button 1 is low, digital reads. Right, high, low. We want to flash them. That's fine. Oh, hang on. Right, hang on. Else. I think that needs to be else. We don't need to read any buttons at this point. Oh, okay, right, hang on. So we want it to read button 1 to flash those the left indicator. Else, we want it to. We put a little bracket in there. we want to copy that. We want to digital write amber 1 and 2 high delay. Copy that. Then we want amber 1 and 2 low delay.
Right.
Right, so that has done. Right, that has done what I've expected it to do. We've worked it out, I think, to a degree. So now we've got the lights on and the indicators are on the hazards. So we've told it that if this is pushed, it's going to blink this LED, or else it's going to blink the hazards. So this is where we can then do an else if, I think. So if I copy this line of code, paste it there, and do else if digital read button two is low and button 1 is high, we're going to digital write amber 2 by low. Yes, right. We've sussed it. Oh, we got there in the end. So here we go. That's the sketch. We've got our hazard lights flashing. Push this side. Left indicator blinks. Let go. Hazards. Push this side. Right indicator blinks.
There we go.
Hazards.
Nice.
Fantastic.
We got there in the end. So let me just summarize it one more time. So we've told it to, when the left button is pushed and the right button is not pushed, it's going to flash the first LED. Or else, if button 2 is low, so we push button 2 and then button 1 is not being pushed, it's going to flash the right indicator. Or else, if none of that is going on, it's just going to flash the 2 as indicators. And pushing both actually does nothing, but yeah, you can then tell it if you're going to push both, it could turn them off or whatever. But yeah, I think that's so this has all been on the fly. Let's quickly write code, and as you can see, you know, it doesn't always work the way you want it to work first time. You just got, you know, it's quite simple, but in a way it's a bit over simple, and then you overlook things, and then it comes to you. So yeah, I hope you like that little demonstration of using push buttons to do different things on your model.
Yeah.
Okay.
So not that you would use this, but you know, say for example that DS Modz and Vintage, if he's on one of his like shows and he's showing us, you know, and he wanted to make it more interactive, you could have like a little button panel well away from the model, and then, you know, the kiddies come up or whatever, they can have a play and push buttons and make the indicators work on the, you know, on the model, and it's, you know, it's good interactive fun. So anyway, oh god, that's me. That's my little advanced lesson for tonight. And I'm glad it worked. Right,
I'll just go through this chat and then we'll sort out the goodbye. So D Harry says gone, that was for the spammers. Steve131 says spammers, nice one, D. D Harry says evening at Steve131, how's you, mate? D Harry said yeah on both channels, Steve. Dave McBill says at D Harris, no, it was the middle of the strip. That's referring to his LEDs. Yorkshire Crafter says, yeah, at D Harris keeps us safe on stream. And then Steve131 says, all good, sir. And D Harris says, not nice, Yorkshire Crafter. If any youngings watching any stream on anyone's channel or any build, yeah, I agree with that. And then Yorkshire Crafter says, true at D Harris. And then D Harris says, how's the family, Steve? And then D says, oh, hang on. This one, D says, you could use it on the Sturbart.
Yeah.
There you go.
You can do anything, yeah.
And Dave Mac Build says, great show tonight, guys. Thank you, Dave Mac. So.
I'll cover on me. I was going to say, you know, another thing you could do with this is actually particularly, Dave say, as you know, bus enthusiasts know, the Routemaster didn't have hazard lights. So at the moment, the Routemaster's flashing its hazard lights. So instead of using momentary switches for this, you could use push button switches that click. So what you could do is push the button in and it will hold that down. And then depending on which way you can't see anything because it's too bright, but depending on which button you push and which way your model's displayed, you could set an indicator to flash permanently on one side if you wanted to. So yeah.
Alan Key says, are you going to upload this?
Yes, I can do. Yeah, I will save this. I will save this code in the drive. Where the link is in the description below. It's named Headlights and Indicators.
Right. The lessons that I do as well, they're also on the OneDrive as well. So, right. Well, I think we've gone on quite a bit tonight. We've done really well. I think, Jack, do you want to do your goodbye first?
Yeah, thank you for watching. Make sure you leave a like and a follow and subscribe and all that. I hope everyone enjoyed the show tonight. And yeah, we'll see you all next week for another Arduino show.
Okay. Oh, schedule. Right. Tomorrow is the Crafton quiz hour. That's at 7 p.m. That's on Horlixs Channel, Northern Model Builders Channel, Yorkshire Crafters Channel, and Crafty Chris's channel. So you can find it anywhere, really. That's at 7 o'clock tomorrow night. Friday is to be confirmed. Didn't you say something about you might do a little bit, half an hour, Harley?
Yeah, I'm just going to do a quick half-hour show. Basically, what it's going to be is I've had quite a few comments or messages about the mod I did on the Routemaster for the, you can't see the logo, but the push buttons on the front of the case. I'm just going to do a very quick catch-up show, just explaining again how I did it, and just re-explain in a shorter video what I've done, and just show examples. So yeah, it's just going to be a quick catch up on that, because I've had quite a few people asking me questions, and I appreciate the video I did do it on went on a bit. So I'm just going to do a cut down version of just based on that.
Okay. So. And then I do believe DS Models and Vintage. It hasn't been confirmed, but we will be going live after. Saturday we have DS Models and Vintage doing his bus. Any of his buses, he's got so many. I think that'll be at 8 o'clock. And then Sunday, you've got me doing a rant at 6 o'clock. And then we've got the Northern Model Builders show at 8 o'clock. Then Monday, it's back to Crafty Chris and Yorkshire Crafter, because they're doing the Disney Dollhouse. That's at 7 o'clock on both their channels. And then Tuesday is Christine. She'll be doing her Eddie Stobart. That's at 8 p.m. And I did that without writing anything down. So, yeah.
Nice.
Brain's on fire today. Right. Right. Do you want to do your goodbye, Horlicks? And then I'll close.
Yeah, I mean, your brain's on fire. Mine's fried now. But no, I actually really enjoyed tonight. And, you know, it was nice that it wasn't so simple, because we had a little bit of troubleshooting to do. And that's all about learning, isn't it? and that's what this is about. So, yeah, really enjoyed tonight. Thank you all for watching and thank you to everyone who is still here and being patient through that. Really means a lot. And yeah, I will see you on the next show. So until I'll see you I'll see you tomorrow on the show. But yeah, till then, good night.
Okay. I'll just close up with this chat. So Alan Key says thank you. D Harris says excellent stream, gents. See you next week. Thank you, D. And D Harris puts 2 weeks of rant as well. Actually, I have got some rant to do. And then DS Models of Vinci says excellent show. Thumbs up. Wash hands.
Yeah.
Okay, so it just says to me to say thank you for everybody chatting in tonight. Thank you for everybody who's watched it. Yeah, we are really enjoying the show, and we're very excited when it comes around to it. I know I'm getting a bit more confident with things. So yeah, thank you everybody for coming on tonight, and we'll catch you next week. When I think I'm doing a speaker next week, but I'm not sure.
So I reckon
it's buzzer again with different frequencies.
So I've just to add on to that, Mark. I think we give you a couple of weeks, and then you can write your own code.
Yeah.
Yeah. I knew I to see Mark write a bit of code on his own.
No.
Yeah.
I just need a bit more practice. It's getting in there. I just need it's all the curl-ons and bits and pieces like that I've got to remember. So yeah. I bet I've got to go down back.
Thing is, though, Mark, I'm going to disagree with you because when I did my code, you picked that up straight away. Oh, I know what you've missed. So you know what you're doing.
I can see it. It's just putting it to practice.
Yeah, I know you mean.
Johnny Dave says, great show. Thank you, Johnny Dave.
Thanks, Johnny.
D. Harris says, night all. And he also, night all. So, goodbye from me. We'll see you next week. And, yeah, have a go yourself.